You're listening to the Identity at the Center podcast. This is the show that talks about identity and access management and making sure you know who has access to what. Let's get started. Welcome to the Identity at the Center podcast. I'm Jeff, and that's Jim. Hey, Jim.
Hey, Jeff, how are you?
Oh, not so bad. Yourself?
Good, except I've been building more tables than a carpenter today. Only thing is, the tables I build are in Microsoft PowerPoint.
Well, I was going to say you're quite handy and quite the construction, but you just kind of totally blew it away there with the PowerPoint comment.
Yeah, and the tables that I built were also not very attractive. Right.
I'm guessing it's probably something built into PowerPoint, right? So it's kind of the standard default blue margins or whatever, right? Did you check the box for, header row and alternate, banding of rows, things like that? I mean, there's just so many things you can do, man.
I did it all. I'm a true artiste. No, but I sat there thinking, man, I'm working so hard today, and then I looked out my window and there was somebody running the weed whacker because we are here in the summer in the Northern Hemisphere. Yes, the world is round. And, it's like 98 degrees Fahrenheit outside. So that's very, very hot in Celsius. And it was...
No, she didn't try to do the math there.
It made me realize that I've got it pretty good.
Yeah, nothing but first world problems, right? If I think if you're working in PowerPoint, you're probably doing okay. But, I know some people like to work outside with their hands too. So whatever makes you happy and brings you joy or fulfillment or money, or ideally all three, even better, right?
That's right. That is the truth.
So I know we're going to get to a topic today that I know you and I have some interest around getting SASE, right? Secure Access Service Edge, and talking about Identity Based Segmentation. And we've got a guest that we're going to bring in to help with that. But before we get to that, do we have any announcements that we want to bring out to our listening audience?
Yeah, so our friends at KuppingerCole hold their annual European Identity Conference in Munich, Germany in September. So it's September 13th through 16th. And it's either in person or online. So my thought was, I'll just go there in person, Jeff, and submit it in my expense report. I'll try to make it to the conference, but I'll definitely make it to Munich. Actually, I did check because I was like, I wonder if Oktoberfest is happening, either at the same time or directly after. But unfortunately, Oktoberfest was canceled. But more importantly, the conference is still going. So for folks who are able to get to Munich, highly recommend getting there. And if not, the online option is a viable option as well.
Yeah, I feel like conferences have kind of figured out the online component here, especially over the last year for obvious reasons. But, I guess the question would be, and it's not a question for me, it would be, if the conference is in September and Oktoberfest, I'm thinking is in October, I don't know if there would be much overlap there.
Actually, I believe most of Oktoberfest, because Oktoberfest is over 2 weeks long, actually, most of it is in September. So it falls between the end of September and the beginning of October.
Well, I learned something new, and I guess that's probably where we'll end the show on a positive note. Hopefully some people learned it, and thanks for listening. Now, all right, so let's talk some identity here. I mentioned our topic around Secure Access Service Edge, or SASE, as you're going to hear us refer to it. And then also identity-based segmentation. These are both things that we see a lot, especially when it comes to zero trust and how the world is evolving from a security perspective. I'm very excited to have Harry Sverdlove. He's the chief technologist at Zscaler on with us. Welcome to the show, Harry.
Thanks, Jeff. I'm really happy to be here.
Yeah, thanks so much for joining us. And one of the things that we like to do before we kind of get deep in the topic is really kind of learn more about our guests and their background in the identity space at large. So maybe if you can just take a couple seconds here. How did you get into identity? Is it something that you chose or did it choose you?
Well, I'm old enough that I come from a generation where nobody studied cybersecurity or security in college. I came through, I studied electrical engineering, computer science at MIT, and got into the business of software development and secure software development, and ended up working later on in my career at Rational Software, where we worked on automated testing systems. And then it just sort of evolved. And all of a sudden I found myself, I was working on identifying secure websites and then looking at vulnerabilities, and did a stint at McAfee, and then eventually went to Carbon Black, or Bit9 as was at the time, as their CTO. And after about 8 years left and founded a company called Edgewise Networks, which was acquired by Zscaler about 18 months ago. But the thing about security is it's like a drug. Once you get into that field, you're hooked. Nowadays, of course, they're teaching it in school, but when we started, nobody talked about security in those days.
Yeah, absolutely. I think we're all kind of learning and gaining knowledge as we go. I mean, the hot topic or the threat du jour of being ransomware. I'm wondering, I want to segue ransomware as kind of a focal point, and wondering how identity-based segmentation helps with that. I mean, I know there are different approaches that are available within the market. Maybe talk about the approach that you guys take, but also kind of help to educate the listener, because I think one of the things about the podcast that we want to do, obviously we want it to be entertaining. We do a marginal job at that, but we want it to be very educational. So, kind of talk about the different approaches that are out there in the market for identity-based segmentation and how they can help prevent ransomware attacks or thwart them anyway.
Well, I think it's important at this point to actually take a step back and ask, what is segmentation? And segmentation is restricting who can talk to whom. And the whole idea behind segmenting is to keep things that are supposed to talk amongst themselves separate from things that aren't supposed to talk in. And the whole idea behind that is to address things like, for example, ransomware. A ransomware attack, let's say it attacks your system and it encrypts everything. Well, that's bad. But that's not as bad as if it then takes the network and encrypts everything else on your network and every other system in your environment. And so the idea behind segmentation is, I want to limit that blast radius. I want to restrict access to things for only things that require that access. Now, how do you do that? There are lots of ways you can do that, and that's where this concept of identity comes in, which is the most secure way and the most flexible way in today's modern world to define what should be talking to what, is to understand, well, what is the what? What is the identity that we're talking about? And to kind of take you back a little ways, once upon a time, i.e. in the old traditional networks, everything was, you'd go into an office, everything was wired together, and you could do segmentation by literally, almost like cubicle walls. You could put, firewalls between different areas, and nobody could talk to the other side without some exception. And everything was based off of these sort of walls that were placed in physical or geographic locations, and you would monitor who goes between the two, who goes within the walls. The problem is that we live in this virtual world now, and you're computing from home, and you're computing in the cloud, and you're accessing cloud services, and you're in a coffee shop, and there are no walls. And so how do you decide, well, what am I going to base my restrictions on? At the end of the day, the way you do that is based on identity. If you're a person, it's understanding who you are. Are you who you say you are? If you're a piece of software, it's understanding, are you that legitimate piece of software, or are you some piece of malware? And so identity-based segmentation is all about defining or understanding what is the identity of the thing communicating, and is it allowed to communicate with whomever it is trying to do so.
Yeah, so we hear a lot of talk about microsegmentation. We need to have microsegmentation. And let me ask the question this way. Do we need microsegmentation just of kind of the enterprise assets, servers, or do we need microsegmentation of the endpoint devices?
Yeah. So I'm going to give you my little pet peeve. I actually, even though I developed and built a company around microsegmentation, I don't like the term microsegmentation. I like the term segmentation. It's just, we added and we call it microsegmentation because what we said is, well, we need to be more specific. It's too general. But a microsegmentation, often people think, well, that's really small and really granular, and there's going to be billions and billions of these rules, and it's complex. It doesn't have to be. You can use microsegmentation to isolate or segment an individual person, an individual process, but you can also do microsegmentation across thousands of systems. And to answer your question directly, well, does it have to be at the users and everywhere? In an ideal world, yes. In an ideal world, everything that you do online whether it's computing or whether it's as a user, whether it's as a business service, should be controlled or restricted in terms of who it can talk to and and how it can talk. And the reason is because, well, there is more, it's just sort of a general paradigm today that there's more bad than there is good happening out in the network today. It's just a reality. It's often where this idea, often called zero trust comes from, which is the idea that just assume your network's compromised. Heck, assume your computer is compromised. Heck, assume you're compromised. Now that you've assumed everything is, if you will, quote unquote, dirty, how do you now decide, how do you secure yourself in that dirty world? And that's segmentation. We can call it micro-segmentation because we're getting very specific about it, but it absolutely is needed for users. It's needed for the Google Docs and the web services you use. It's needed for large data centers because it prevents, when an attacker comes along, it prevents them from being able to propagate, which is, at the end of the day, almost all attacks happen because of some form of malicious or unauthorized communication, either getting in or walking around, and lastly, taking whatever I found and getting out with it.
It seems to me that the complex part is that even if you just say the enterprise assets, right, the servers, the switches, everything that happens in the data center and out, or cloud or whatever, at some point you're talking about a lot of connections, right? Say each endpoint, each server needs to communicate to 5 other combinations of IP addresses and ports, things like that. You start to have this mesh of connectivity that is quote unquote normal or allowed for kind of what I would call east-west traffic, right? So peer level communication between these devices, right? Isn't that what you're trying to, where you're trying to stop the unwanted traffic? So again, so like maybe the application server is compromised, right? That it can't reach out to other application servers in its same zone and start infecting them with malware. So I'm trying to get an idea for, how does a system handle that much complexity, right? And that potential amount of change? Is it using some kind of artificial intelligence, or do you have to kind of map out all of these proper connections and maintain some system that does that?
No, in fact, the essence of your question, you're absolutely right. It explodes, or sort of explosive, in terms of how many connections, how many addresses. And that's exactly why identity-based segmentation came along. Sort of think of it as this metaphor I like to talk about, which is, how many phone numbers do you have on your phone in terms of all of your contacts? The answer is many, and it's growing by the day. But now let's say, how many contacts, how many identities do you have on your phone? It's much less. A given identity, like let's say Jeff, might be one identity, but might have 12 phone numbers in your contact list. If you're doing segmentation based on addresses, you're going to have this explosive growth. This one server needs to talk to these 5 other servers. It can use one of 10 addresses. Each of those 5 servers can use one of 10 addresses. All of a sudden, you're in the thousands and millions and tens of millions of different possible permutations. But now if you take a step back and actually map, well, what are the identities communicating? It's one server talking to 5 servers. So at most, it's 5 pathways, if you will. Or you might actually group them together and it's just one. This one guy can talk to that group of 5 gals over there. By using identity, you actually achieve multiple orders of reduction of that complexity. So that's really important, and that's why everybody talks about identity-based segmentation is the way we go in a world where address space is just ridiculous. As far as, well, then how do you now manage some of that complexity? This is absolutely one of those areas where machine learning comes into play. And when you start doing pattern graphs and pattern analysis and cluster analysis, you actually you're able to visualize, and then by visualize, I also mean interpret into, computer policy, how things are communicating, how they're communicating as communities, and then recommend a set of, these are identity rules, that these are your clusters, and these are how they're communicating. And then once you have that, now you simply, if you have an identity-based segmentation solution, you simply apply that observation as a policy. And all of a sudden, Bob comes along and starts trying to talk to Jeff. Well, Bob's a different identity, even if Bob has stolen your telephone number. And so he's calling from your number, or the equivalent in computer terms is, I've gotten onto your system. I've now hijacked your system. I'm running something malicious. I'm trying to talk now to your database. I'm on the right system. I have the right address, but I don't have the right identity. And that's where identity-based segmentation can come in and say, well, wait a second. Sorry, you're not Jim.
So when we look at this market of identity-based segmentation solutions, it seems like there are different approaches, right? There's like the hypervisor-based, agent-based, network-based. What are the pros and cons? Why are there so many different approaches? And what are kind of the pros and cons of those different approaches?
Sure, yeah, absolutely. And there are definitely pros and cons. And the reason is security always lags innovation. That's just sort of the world we live in. So we have innovated. We've created new technology, new address space, virtualized computing faster than we've been able to sort of chase along with security technology. And that's one of the reasons why there are different technologies, because when you start with a hammer, everything starts to look like a nail. But let's take a look at some of them individually. So you have host-based or agent-based segmentation. And kind of the way I like to think about this is, let's talk about the network in terms of all of the roadways. And host-based segmentation is like having somebody in your house, making sure that you're you before you go out to Jeff's house. And then there's an agent sitting in Jeff's house. So we like agents spying on everybody, right? It's agents sitting in Jeff's house saying, wait a second, who's coming at the door? Oh, I see, it's Jim. And then they let them in. And the advantage is it doesn't matter what pathway you took. It didn't matter how you got to Jeff's house, whether you took a hovercraft, whether you took, I-95 or you took a bunch of side roads. We're validating, and a host-based segmentation is validating that you left your house and it is you, and you got to Jeff's house and it is still you. And so it has that advantage to be independent of your environment. You don't have to change your network, so to speak. And it's very advantageous, for example, when you're in the cloud or in a virtual environment and there's really no other good place to check. Well, what's network-based segmentation? Identity-based segmentation. That's similar to having a bunch of toll booths on the roads and funneling traffic through those toll booths so that when you drive through, it makes sure, oh, you're Jim. I see you're headed to Jeff's house. Okay, go through. That has an advantage if you can't get agents into people's houses, right? But the disadvantage is I really don't know that it's you. I'm just looking, the metaphor breaks down because it's not really you going to Jeff's house. It's you talking to Jeff. And so I have to kind of look and say, well, it sounds like Jim. And so the network-based segmentation sort of looks at the packets, looks at the conversation, divines, oh, this looks like SQL or this looks like web traffic, and then makes a determination. It has that advantage of you don't have to be in people's houses to make this decision. It has a disadvantage that you're not really getting full identity. You're really more just validating that you're talking like Jim. Hey, you sound like Jim. You have his cadence. Hey, let's go through. And then lastly, there's hypervisor-based segmentation, which is hard. My metaphor totally breaks down because roads are physical and hypervisors are physical, but the roads are virtual in that world. But it's at that underlying layer where the underlying fabric that's supporting a virtual network is doing the monitoring for you. It has an advantage that it's ubiquitous. It's sort of that underpinning, the groundwork, the Department of Transportation, I guess, might be the metaphor. And it can see all the traffic going through. It has similar disadvantages of the network because, again, it can't really tell who people are. They have to watch things. And the other disadvantage to hypervisor bases is it only works if everybody in your network is using the same hypervisor technology. But each one has an advantage in terms of how much change do I have to put in my network so that I can get this benefit from the security.
It seems like there's a lot of different ways that organizations tackle this. I would imagine that it's not a one size fits all, right? There's probably a combination here that needs to be put in place to really kind of effectively make sure that the appropriate resources are being accessed by other appropriate resources, whether it's a human or a bot or whatever. And I think there's a lot of organizations that struggle with where do you actually get started and then how far do you really need to go? And I guess that's my question is, where do you start if you're looking to go down this route and you maybe have a relatively wide open network where, maybe it's a little more the old school thinking, right? Well, once you're in the front door, you can kind of go anywhere you want. That's kind of going by the wayside. At least we hope it is from a security perspective. Where do you start? And just how far do you need to go? Do you need to set up? I know you don't like the word microsegmentation, but I think in the terms of it, right? Yeah. And is it for, this specific PC or app or set of apps or floor of a building, right? How should people be thinking about this?
Right, absolutely. And it's always that trade-off between manageability and security. So in a perfect world, or maybe it's a bad example as perfect, but in the most granular world, every single process, every single detail is a managed asset, and I'm going to control who it talks to. And then I get this really high intense security, but then I do have this explosion in policies. Even though it's not address-based, even identity-based, at some level of granularity, you're dealing with millions and millions of possibilities, and it becomes unmanageable. And the challenge, of course, is if you go too far down that road, not only is it difficult to set up, it's difficult to maintain as things change, because things are going to change. Now, if you go too high, and you end up with kind of, often we call it the M&M security, hard on the outside, soft on the inside. And you say, okay, my whole data center is one entity. Well, it's really easy to manage. It's, one entry point, if you will, but really terrible security because it's also one point of failure. Somebody gets in, the blast radius is the entire M&M. And so my recommendation to folks is it really is, as you said, it's not a one size fits all. So therefore, there's not a one approach fits all. It gets back to, well, where is your risk? Where is your risk tolerance? If you are a financial services organization and you have a trading platform or some investment platform, and that's your core IP, that's your secret sauce. Without it, you're gone. You're out of. Then that critical asset is something you probably want to prioritize first. And I want to secure this so that unauthorized folks and or processes can't get in. But it may be, for example, and many customers will start on the outside at their users. With the thought process, and it's not a wrong thought process, being that at the end of the day, most attacks do start at I don't want to call it the perimeter, but at the edge. They start at the user, either because they infect the user's laptop, or they're monitoring in a VPN at a coffee shop, or they send an email, but they're starting at that edge, and then they're working their way in. And so you may decide, I'm going to start by securing my users, and I'm going to put segmentation or identity-based security and restrictions in on those systems so that when they come into my organization, at least I know they're safe. And then I start building, then I start going at tighter and tighter concentric circles until I get to whatever the core features are. So there's no wrong place to start. I think the one recommendation I would make, and I always make this to different folks, is start with some place that is tractable. It's a platitude, but this idea of don't boil the ocean, it really matters, not just because you'll fail, but you'll be disheartened. And once you're disheartened, then you throw up your hands and you go, oh, and then you start making bad decisions. So start with something that's tractable, and it might even be a small application that's not business critical, that's not your highest risk, but you need to gain confidence in whatever tool you're using. And then build on that success, find a process, repeat it, because at the end of the day, segmentation is a rinse and repeat. If I'm doing it for a user, then I can do it for this other user and this other user. If I'm doing it for a business application, I can repeat it for the next application and the next application.
That was a fantastic answer, and I love all of the analogies that you used. You had the highways, the M&Ms. Got me thinking about M&Ms. And Jeff, I think at some point we need to have a discussion on what's your favorite M&M, like we did with the Pop-Tart discussion a few episodes back. So, but Harry, I wanted to move on to our next topic, if I could, and talk about Secure Access Service Edge, or Sassy. I mean, it's on the tip of everybody's tongue now. So it's the hot thing to talk about in our space. Help our listeners and ourselves understand more about what is Sassy and why is it important?
Sure. Yeah. No. And first, kudos. I believe Sassy was first coined, or at least put into mainstream use, by Gartner in 2019. And kudos for coming up with an acronym that's fun to say. This is why when we were talking about identity-based segmentation, you didn't ask me about IBS, because nobody wants to talk about IBS, but Sassy's awesome. So kudos for a great acronym. And it really stems down to, as we started talking about this explosion of computing, where you have cloud computing and you have the idea that your data center is half hosted by you or maybe in the cloud. More traffic when your employees is heading to cloud services that the companies don't even manage. More of your critical assets are even on areas that you don't manage. And we used to say, excuse me, in security, that the perimeter is gone. Sassy is really a variation on that says, the perimeter is not gone, it's everywhere. And it's the idea of moving the perimeter down to the true edge, which is every entity that accesses your environment, your users, and actually building a perimeter around the user so that whenever they do access to, whether it's access to your data center or whether it's access to Google Docs, which is just as critical for your company, or they're accessing your email server, which might be running on Gmail, again, just as critical, that you're applying both. You're putting a security edge there, and you're applying security across the board. And the way that sort of Sassy works, and it's been an evolution as it's coming, is it's almost always it's security as a service. There are some Sassy implementations where you literally have a box that you might plug into your computer or plug your network in. But nowadays, Sassy is generally considered to be, it's a piece of software that runs on your client, and then any network connectivity that you do, it validates who you are. So identity is going to become really important again. It validates what you're doing, and then based on who you are, what you're doing, it reroutes the traffic to, oh, okay. So it has a couple advantages. It not only is it used for performance, because it can find the least minimum path, the fastest path to get to whatever server or service you're trying to work through, but because it becomes sort of a choke point, but not in a performance impacting way, but a choke point for gathering traffic, it gives you a secure encrypted channel where now there's a central place that you can apply policy. I want to make sure that any communication coming from Jim's laptop is encrypted, or I want to make sure that he doesn't, DLP, he's not actually sending out unencrypted social security numbers. And that I want to make sure that when he's accessing my company servers, for example, it's not 3 a.m. Or I might want to take other attributes into account. I want to make sure that he's not doing this from North Korea. So there's a number of things that you take into account: geo, identity, what you're doing, and how you're doing it. And all of those get combined into this sort of this acronym, the SASE acronym, Secure Access, Secure Edge, that allows a centralized control of a perimeter that has now been exploded to all of the endpoints. This has become really important, by the way, in the last 18 months, where, due to global pandemic reasons, a lot of the workforce is now truly remote and working from anywhere. And whereas before, at least most of the time, your employees were working at home. Were working in an office, and you could secure that. You had a perimeter, and then what you did in those days, and in Europe, many companies still do this, is you had a VPN. Oh, when I want to do company stuff, I VPN in. Now the challenge, of course, is often that VPN now lets anything on your laptop into my network. And that's a security risk. And then the other challenge is, well, I want to use Google Docs, and I want to use Gmail, and I want to use Salesforce, and I want to do these other things. I don't need to VPN in. I want to go straight to the cloud. So why should I take the performance hit of having to offload all my employees' traffic to some sort of boxes on-prem? And hence this explosion in the practicality and the need for SASE.
Well, it strikes me as you have a lot of this heavy footprint when it comes to that kind of thing too, right? You mentioned, it used to be a box, right? I think of kind of like it's this filter, right, that sits in between some device and something else that says you can do what you are allowed to do or what you aren't allowed to do. And there's going to be naturally, I would imagine, performance and any number of reasons that would do that, whether it's network latency or even, just thresholds of, we've seen VPN concentrators go down because everyone is trying to log into VPN at the same time, right? That kind of process. I think you mentioned software really kind of driving SASE at this point. Is that predominantly the way it's being done, or do you still see hardware versions of SASE out there, or has it shifted more to that agent-based type approach?
It's definitely shifted more to the agent-based, and not just on the endpoint, but also in wherever traffic is being rerouted into the cloud. And the reason is so that you can have elastic computing, right? Let's say if you were building your own appliances, or you're a company and you want to offer SASE to your employees, you have to reroute all their traffic to your boxes or your computing power. And as you hire more people, you need more computing power to handle more bandwidth and more. Let's just say everybody in your office starts running Netflix or something. It is like all of a sudden you need the computing power to process that. And by being in a cloud and being virtualized and elastic, SASE providers can scale at, basically gain benefits of economies of scale, and can handle billions, if not trillions of transactions every day. And let that be someone else's problem. So we're seeing more and more of that going to as a service and software based.
So a big part of the SASE approach is routing all the traffic securely. One major product component of that is the secure web gateway. What are secure web gateways? I started researching it. It sounded a lot like kind of a proxy approach, but more, right? Maybe more capabilities. But am I on the right track? Does it serve any kind of proxying function? Does it cache any data? Is it used for, either content filtering or alerting if somebody's wasting time at work going to porno sites and things like that. Like,
well, it's certainly the answer is yes. Although I wouldn't know anything about that last point. I don't know where you got that from, but but if we go back, when I was talking about identity based segmentation, I was talking about, well, security in that point is the identity of who you are and who you're talking to. Well, if you don't have access to who you're talking to, if you're talking to something unmanaged, let's say a web service or the great unknown, the dark web, the internet, these sites you're speaking about, well, you can't really validate identity there. And so you have to that's when solutions like secure web gateways and others, you need to look at the content of what you're saying. Right, you need to look at that content. And so, wait a second, I want to set policies that, and by content, for example, I mean what URL, what domain are you going to? How much data are you uploading to them? Or in some cases, inspecting that data for DLP. Are you uploading sensitive data, or are you downloading something that might actually be a virus? And so secure web gateways is a way to filter internet traffic or TCP traffic through these boxes, virtual or physical, it really doesn't matter, and then apply a set of policies. Those policies may be, there should be no pornography in my, none of my employees should be accessing pornography. But the policies may be other things like nobody in my company, when they are outside of, let's say Europe, should be able to access my source code system. Let's say, for example, if I'm European based. So they may be geocentric policies, but it gives you a chance to do stateful inspection of the communication and then apply policy therefore.
Are there any clearinghouses for blacklisted websites that, if I'm a administrator of a secure web gateway, rather than kind of blacklisting all the sites that, are bad myself, like maintaining a list that I can point to some third party?
Yeah, and in fact, it's now built into almost every secure web gateway out there, including Zscalers, of course, as well. Which is they have the SWGs have their own threat intelligence research team that are doing that work, so you don't have to, and they're feeding that intelligence, that threat intel database, into their filtering, so that it can be as simple as, depending on the vendor you go with, I deploy a secure web gateway and I do a checkbox and say I want to filter out all high risk websites, and then offload that determination to the threat intelligence of that vendor. But in many cases also, secure web gateways will allow you to give it a feed and subscribe to different threat feeds that are out there that keep track. Because of course, the real estate of what's bad is growing faster than the real estate of what's good as well.
I would imagine that kind of puts it into the benefit of, if you're using something that's more cloud native, right, as a platform to do this, it's probably going to scale up better, especially when you start thinking about just how addressable the internet is, right? And the sheer number of things that you need to try and keep a manage on from a filter perspective. I guess that's the way I'm thinking of it. I don't know if there's any benefit trying to do that versus the cloud versus maybe more a traditional kind of appliance-based approach.
At this point, the only companies I know that are not either haven't moved to cloud native and have no strategic direction to do so would be things like three-letter agencies and others, where they absolutely can't lose primary control over their traffic, over their policies, for high national security reasons or regulatory reasons. But other than that, if there's really no reason at this point that you shouldn't be going to a cloud native solution that can make the updates far quicker than you can, that can scale the compute power far better than it takes for you to order a new box or a new set of CPUs or a new rack, because as it turns out, now it turns out your employees are in fact browsing Netflix or something that's high bandwidth.
So what's the intersection then between a secure web gateway and Sassy?
Sassy includes secure web gateways. Sassy is kind of like an overarching umbrella, and it's still in its nascent stage. Remember, as I mentioned, I think Gartner first brought it to existence in 2019. So we are still talking about a relatively new acronym, but it is a combination or an amalgamation of multiple things. It's secure web gateway. It's often integrated in with identity management. In some cases, it has CASB functionality, which is really getting into the specific conversation, and if you will, and making sure that you're not saying something or doing something that can be exploited or that could be viewed as malicious. And so there's a lot of different security technologies that now get put on top of it. So imagine, for example, once you set up that framework where everybody's the edge and everybody is routed, encrypted to a cloud native broker, let's say. That broker can do many things. It can apply security policies. It can inspect the traffic and do things like CASB or WAF. It can do performance management, so it can find the quickest route to wherever you're going. It's a single point of management and a single point where you can consolidate a lot of policies. And so from that sort of administrative point of view and that consistency point of view, it's a lot of things are getting put into the Sassy bucket for good reason.
So Harry, I think that was a great answer, by the way. I've been putting out, something I've been starting to do is I've been putting out on my LinkedIn when we're going to have a guest and ask people to volunteer questions. And we got a couple this week from your colleague, actually, Brian Deach, who was kind enough to be on the show with us in the past explaining ZTNA. And so his first question was around how complex is it to map zero trust to identity without incurring crazy latency?
It's definitely an interesting when we talked about the different. And by the way, thank you, Brian, for popping questions on top of me. It goes back to when we look at those different identity-based solutions, host-based, network-based, hypervisor-based. Each one can have a different impact in terms of latency. Right. So, for example, if you're a toll booth on the highway, as we know, toll booths often cause traffic. And there are ways to speed it up because we all get easy pass or fast pass and hopefully get through it. But it is a choke point, and therefore that incurs latency as this network security device is inspecting the traffic, making sure that it matches whatever the policies are, trying to identify things. And so often when you have a network-based segmentation solution, you have to deploy that, scale it with an understanding of how much bandwidth you're going to need. One of the advantages of a host-based solution is it distributes that processing to all of the nodes, to all of your endpoints. And so it doesn't have the same impact, but there's a decision point, right? The host has to make a decision to allow a connection or deny it. And in the case of Zscaler, we do this in less than 5 microseconds, which is faster than a traditional firewall, but there is still a cost, and it's definitely important as you look at different solutions to ask that question: how will it impact both not just the latency but the capacity of my network? Is it going to encapsulate things and double my traffic, and therefore I need to have double the capacity? Is it going to impact that? And different approaches can absolutely have that impact. One of the things we do, of course, at Zscaler is we strive to minimize that, to make that as negligible as possible, but it's always something that you got to be wary of.
Okay, cool. Brian's second question was, how did you come up with the concept of a ZTID? I'm assuming Zero Trust ID?
Yeah, Zero Trust Identity. So this is an interesting, you talk about identity quite a bit on the podcast. And what is identity? Well, if you're a user, we kind of are starting to get used to that. Oh, it could be biometrics. It could be, my fingerprint, my key fob. It could be a lot of different things that I might interact with, or, that idea of something I know versus something I am. And we kind of understand that for users, but what happens when you're doing identity-based segmentation on workloads, on your back office, where there's nobody sitting at the keyboard? So you can't say, okay, I'm going to text you a code, please enter it before you submit this, before the order processing system saves the order into the database. And so you need some other ways to ascertain identity. And this came back to my days when I was at Carbon Black, and we were building both application whitelisting and EDR solutions, where we're capturing all of these different attributes. And I took a look at the problem and said, well, if you're a workload, we know certain things about you. We know your hash. We know your certificate if you are digitally signed. We know the CPU ID, the BIOS ID. We have all these attributes that we can use to ascertain that you are who you say you are. And more importantly, they will change if you aren't who you say you are. That's sort of the key aspect. If somebody comes along and puts a malicious version of Microsoft Word, or goes onto a system and starts using a new piece of malware, a new piece of software, that's going to have a fingerprint that we can measure in its hash, in its PE header properties, in its file location, and those properties taken together is what we call our Zero Trust ID, or our fingerprint. That's what we use to establish identity when there's no user. And one of the other things that was, I learned in the days of application whitelisting is the challenge with whitelisting, blacklisting is how do you categorize something as good or bad? If you're a piece, if you're a virus or you're a ransomware, okay, we can all agree you're bad. But what if you're PowerShell? What if you're Java? Well, are you good or are you bad? So sort of the age-old question of is man by nature good or bad? Well, you could be either. It depends on what you're doing. If you're PowerShell and an administrator's using you to do some remote administration, maybe that's good. But now you're PowerShell and somebody's using you to pull all the passwords and credit cards out of a database, it's probably bad. In the case of a application whitelisting solution, that's a really hard thing to do, and that's why we often talk about behavioral analytics. In the case of segmentation, it's fairly easy. It's based on who are you talking to. So if when you have a policy that says Jim can talk to Jeff, there's two things that are important: are you Jim and are you Jeff? But the other is, are you guys talking to each other? So if Jim comes along and starts talking to Harry, which you shouldn't have started doing in the first place, it's going to be a warning to you. You are who you say you are, but somebody's hijacked you. And now you're talking to somebody you shouldn't be talking to. So another way to look at that is it's identity plus behavior. And that's how you establish trust.
It sounds an awful lot like a man in the middle attack to me, and trying to defend against that.
Yeah, Jeff is standing between you and I right now. So I don't know if he's the one that's actually causing all the trouble.
Harry, you've been really generous with your time, and I hate to pull this. I want to pull this back to a kind of a lighter note before we kind of end our conversation here. And I'm going to probably nominate for the first time ever a listener MVP, and that's going to be Brian, because we're going to also steal his third question that he asked, which was, who would win in a fight, the Stay Puft Marshmallow Man from Ghostbusters or a supersized Pillsbury Doughboy?
I happen to love Pillsbury, but I got to tell you, I got to go with the Stay Puft Marshmallow Man because the dude shoots lasers out of his eyes and he steps on churches. If there isn't an act of militia, outside of shooting lasers while you're stepping on a church, that's a pretty tough guy. I think, whereas the Pillsbury Doughboy, you poke him and he giggles.
Yeah, so I think the range, let me take it to my World of Warcraft experience here, right? The range attack, the poke, if you're a League of Legends player, I think that would soften down the Pillsbury Doughboy quite a bit. I was impressed with a gentleman by the name of Scott Savage who replied to that question from Brian, and here's what his answer was, and there's a lot of logic here, so I'm gonna let me just repeat it here verbatim. Brian, the answer is Doughboy. When you cross the streams of an unlicensed nuclear particle accelerator aimed at Stay Puft, it blows up when cooked. Doughboy would just become a rock-hard, crispy version of the Hulk. Dough, much more than marshmallow. Which hold on.
Yeah, just Bravo is a beautiful engineering response.
Yes, exactly.
Yeah, I guess if you happen to have a bunch of portable backpack nuclear-powered fusion reactors, you probably would be better off hanging out with the Pillsbury Doughboy at that point. But for lack of having nuclear arsenals, I'm going with Stay Puft.
Well, you talk about the lasers, so I can see a situation where the Stay Puft is using the lasers, right, to carve up the Pillsbury Doughboy into these little crispy pieces, and it becomes this nightmare situation where think of Legos on the ground, right? And you're stepping on with bare feet. I mean, that could be pretty bad.
Yeah, no, you would have a lot of shrapnel. I was going to say you'd have a lot of donuts on the ground, but I don't know if that's crossing the streams.
That sounds delicious, actually. Jim, what do you think about this?
Well, my thoughts are that, I can't really see Pillsbury Doughboy getting beat. And the reason is Harry pointed out, like, oh, you poke him in the belly and he laughs. Let me poke you in the belly, Harry. Let me poke you in the belly, see if you laugh. I think the guy's a lot tougher than he lets on.
I think he's good-natured. I don't know that good-natured translates to raw toughness. I might put it this way. Which one would I rather go to a bar and have a drink with? Doughboy all the way. But now I'm sitting in battle and I got to take on, the enemy alien invasion or zombie apocalypse. I'm going Stay Puft.
Well, it's also not Doughboy that's the size of like a little teddy bear, right? The question was supersize, right? Supersized Doughboy.
Oh, is it a supersized Doughboy?
Yeah, it's a supersized Doughboy. So we have to assume that he's, about equal in height to the Stay Puft, right? And then my other thought was, so this is where I reversed science and totally made it not fun anymore, right? I started thinking, well, Doughboy's going to be like, 10 times heavier. If you ever think about a UFC fight, they break them down by weight categories, right? A 10 times heavier fighter would never fight a much smaller person. So,
you got a good point there. I think the weight argument is probably the most valid. The Stay Puft guy, he's how heavy can a marshmallow be? Right. So he's definitely
right.
light, whereas Doughboy, well, we know they're heavy.
Yeah. I mean, he has a weapon, right? I mean, like, I think even a wimpy guy with a gun could beat Mike Tyson, right? If you shoot him with the gun. But, again, another assumption which I think we have to make is that they're both either equally armed or this is a fist fight.
Yeah. Well, it will be a good battle, I'll tell you that. And it would be a very fattening battle to watch.
This is a battle I can get behind for sure.
I think they call that the Battle of the Bulge, but I could be wrong about my history there.
Battle of the Bulge 2 on pay-per-view coming to a TV screen near you. Now, this is the type of conversation I think people really tune in for when they're talking identity, right? Is let's really get to the bottom of things. So thank you, Brian, for that question. Hopefully we addressed it in a manner that was what you were expecting. Before we get things going for this week, I just want to take a second to kind of pass it around real quick for any kind of final thoughts. And we'll start with Harry. Anything that the listening audience can kind of take away and think about when it comes to Sassy and secure web gateways and this whole process around identity and how it relates to both?
Identity, trust, and edge. Absolutely. I think these are all really critical issues. And if, we're dealing with that world where everything is disparate, everything has been pushed out to people's homes, to coffee shops. So I really think that we should be people should, if you haven't already, take a good look at what's out there being offered for Sassy. Look specifically. I strongly recommend cloud native software solutions because they tend to be more flexible, but look for something that meets your needs. The other point I wanted to make, and I didn't get to make this earlier, I know, Jim, you'd spent all day working on building tables. Just to show you I'm in security, I was building bullets. They were 12-point aerial, but they were bullets all day long.
I love it. Jim, what about yourself? Final thoughts?
Yeah, my final thoughts are, well, thank you, Harry, for coming on the show. I mean, you really took these two concepts and boiled them down into a medium that I think people can easily consume and understand. I think that's so important, right? Because these are two concepts there. I was going out, downloading white papers, reading them, and trying to work it all out in my head. So thank you very much. I think one thing for our listeners to do would be reach out to you. I think that you've been very open from the moment I contacted you to get information and start interacting with you. I want people who are listening maybe for the first time to reach out to me on LinkedIn, connect. I'd love to build my network and help you build yours.
Absolutely. And I'm out there on LinkedIn. Feel free to reach out to me anytime. As you can tell, I love security and I love technology. So I'm happy to just continue the conversations and help where I can.
Thanks so much, Harry. And yeah, in the show notes, I'll have a link to your LinkedIn profile to make it easy for people to access. And then also put a link in there for the different styles of identity-based segmentation. It's a document from Gartner that people can check out, kind of give them a little more technical details kind of behind the different components that we've been talking about today. So people can check that out in the show notes. So I think that's a pretty good spot that we could leave it for this week. We'll go ahead and call it. You can always visit us on the web at identitycenter.com. You can follow us on Twitter at IDAC Podcast. And with that, we'll let everyone go. Thanks, everyone, for listening, and we'll talk with you all on the next one. Thanks for listening to the Identity at the Center podcast. If you like what you heard, don't forget to subscribe and visit us on the web at identityatthecenter.com.